Hello everyone and welcome to episode 3 of my electrical age tutorial series. Now in this video I'm actually going to be covering some real power generation, so you won't have to craft yourself any more of those single-use batteries anymore. So let's just get right into it. So to start, the most simple power producing item in this mod I believe is the water turbine. It's very simple. Now to craft it, it's just 3 iron plates, 1 electrical motor, 1 machine block. Let's turn off that. If you want to know how to craft the plates or electrical motor, check out episode 2. So the water turbine, it's got this nice little generator bit and some paddles. And again, most of the things in this mod that are functional have animations and sounds. So this thing is animated, the wheel bit spins, and it has sounds. And its power output is this little bit on the back. Now let's move on to the next thing, which is the wind turbine. Actually, before I move on, let's look at the stats of the water turbine. So it generates energy using a water stream, and its output voltage is 50 volts, and its output power is 30 watts. Now with these things, its voltage will not be exactly 50 volts, and its output power will not be 30 watts. The output voltage is likely to be higher than what's said there, so it's likely to be higher than 50 volts, and its output power is likely to be less than 30 watts in just a normal scenario. If it's raining, that's different, but I'll get into that just over there. So next thing, the wind turbine. So the wind turbine is crafted using a machine block, electrical motor, and 3 iron plates. The exact same as the water turbine, it's just in a different pattern, basically, and that gives you 1 wind turbine. Now the wind turbine, before we do that, let's look at the stats. So it generates energy from wind. Its output voltage is 59 volts. Now that is correct for this thing. It does output 59 volts. Its output power is 160 watts. Now, do not be fooled. Its output power will most likely not be 160 watts. I'll talk about that when I actually get into showing the thing off. And then it says wind area there. Now that has to do with it has an area in front of it where if you place anything, it will basically make the thing less efficient because, I guess you're blocking the wind. That can be seen between these two. You can see that one is spinning much slower than that one. And that's because this one, not only is it lower, it also has this stuff in the way. So that's the wind turbine. And again, this thing is animated. It's not playing the sound right now for some reason. Don't know why. Should be. Probably because it's spinning too slow. That's probably why. And this thing outputs power at the bottom, so its wire connection is at the bottom, and that is changeable, so you can change where which side the power outputs from the bottom using a wrench or using the wrench hotkey. Let's move on to the next thing, which is the small solar panel. Now the small solar panel is crafted using 6 iron ingots, 2 low voltage cable, and 1 silicon plate. If you want to know how to craft the silicon plate, that's in episode 2. Now the small solar panel, it produces power from solar radiation. Now these things are also very simple to use. But with this thing, its output voltage there, you can see it's only 14.8 volts. So that's like a quarter of what you need to power the 50 volt machines. So I'll get into how you can put these things together to get the 50 volts you need to power your machines. And its max output power is 65 watts. Now its output power will most likely be not 65 watts because for the laying down one anyway. For the one that's tilted, the one over there, it might get close to it. But yeah, so this is the solar panel. It's not animated or has any sound effects because it's just a solar panel. It sits there and makes the power from the sun. But this thing, like the batteries, it does have a positive and a negative side, and be careful when placing these things down. The positive side always comes out on the left, so if you're facing that way and you place it down, the positive side will always be on the left. So if you're placing this thing down into a live circuit, just make sure you got your positive and negative sorted out so you don't explode anything, because I've done that before. That goes with the batteries. Batteries have positive and negative side too. These things work basically the same as batteries with how you have to wire them up with the ground, but again, I'll get into that over there. So this is the small rotating solar panel. Now, it's basically the same. Well, before that, it's crafted using 4 iron ingots and 1 small solar panel. You actually use the panel in the crafting recipe. And this is the exact same stats as the small solar panel that's just lying flat, but you can gear it towards the sun. So you basically, when right-clicking, let's just get rid of this. By right-clicking on it, you can change the direction it's facing. So it tells you the angle of the sun, and you can attempt to gear it towards the angle of the sun. Let's just get rid of that. But you can put something in, as you saw there, you can put a solar tracker in there and get the thing to point towards the sun for you for the highest efficiency. So those are the power generating items I'm covering today. So I'm only covering the renewable power. Coal power is next episode. So subscribe if you want to be notified when I post that video. Shouldn't be too far off from when I post this one, because I'm going to be trying to post more videos. I'll try. I'm not a guarantee. But yeah, let's get into the batteries. So all these things, they don't generate power constantly, other than the water turbine, but that thing generates very little power. Most of these things, they don't generate power continuously. Like the wind turbine, the wind is sometimes higher, it's sometimes lower, sometimes the wind's not even there. And with the solar panels, well, the sun goes down. They don't generate power if the sun's not up. So you're going to need somewhere to store your power. So we got these batteries. Now I've already covered the single-use battery in episode 1. But again, that'll probably be covered. I've already covered that because episode 1. Yeah, so let's just get into this. So to craft the cost-orientated battery, it's 2 low-voltage cable and just a bunch of lead. Just 6 lead, 2 low-voltage cable, you get your cost-orientated battery. Now the nominal voltage on this battery is 50 volts. Its nominal power is 250 watts. So you can only pull 250 watts from this battery anymore, and the thing will start to heat up, and once it gets to a certain temperature, it will explode. That's not fun, don't do that. And its energy capacity is 60 kilojoules, which is less. I believe it's half. This thing only holds half as much as the single-use batteries, but it can be charged up. And its internal resistance is 400 milliohms. I believe that is milliohms. Might be, yeah, that's milliohms. And then its actual charge is 50%. Now, I'll talk about that for a second. Now, if you remember from the, the single-use battery, it started off with the charge of 100%. You craft the battery, it starts off 100% charged for the single-use one. But these ones only start out 50% full when you craft them, so you have to charge them. And it has life 100%. Now that life has to do with the energy capacity. As you use these batteries, their life will drop. And that life percentage there is basically directly related to the energy capacity. So when it starts off with a life of 100%, that means it has 100% of its capacity. And if that life then drops down to 90%, it will only have then 90% of its energy capacity. So only 90% of 60 kilojoules. And the life will drop slower when the batteries are being abused, like too much current being pulled, or too much power being pulled, or too much voltage, or too much heat. Yeah. So it might sound complicated, but once you start playing around with them, it starts to feel less complicated. Now this battery, it looks pretty nice. It's got battery. It's got some wires on the side, and these things, they have a positive and negative side. Do not mix these up, because then your circuits will explode. Yeah, and then when placing them down, as of now, the positive side is always on the left side when placing them down. So make sure to remember that if you're placing them into a live circuit. And always make sure ground is connected to negative. That goes with the solar panels. The blue is the negative side. Connect ground to the blue side on the panels and the negative side on the batteries. Let's move on to the next battery, which is the capacity-orientated battery. Now this is crafted using 1 cost-orientated battery and 8 lead ingots surrounding it, and that gives you the capacity-orientated battery. This thing has very low voltage of 12.5 volts, so you're going to need, so that's still only about a quarter of the power needed for machines and stuff like that, for the 50-volt machines. Well, not the quarter of the power, quarter of the voltage. Then its nominal power is 125 watts, so you can't pull much power from these things. But it has quadruple the energy capacity of the cost-orientated battery. and its internal resistance is 50 milliohms. Actual charge, it starts off 50% charged, and it starts off with a life of 100%. And then this is pretty nice. It's got some weird stuff off the top. I don't know. Is that battery acid dripping? I don't know. But again, looks basically the same as the cost-oriented battery. It's just got some like drip things there coming off. And instead of 50 volts, it says 12 volts on the front. So that is a 12-volt battery. So let's move on to the next battery, which is the current-oriented battery. This battery is crafted using one cost-oriented battery, surrounding it with 8 copper ingots. And the current-oriented battery is nominal voltage of 50 volts, nominal power of 1 kilowatt. So you can pull a whole kilowatt from this thing without it exploding, which is nice. Its energy capacity is very low, only 40 kilojoules. And its internal resistance is 100 milliohms, starts off 50% charge, and life 100%. And it's basically 2 small batteries. That's what it looks like anyway. And then let's go to the last battery, the life-oriented, last but not the least battery. There's still one more. The life-oriented battery. So the life-oriented battery is crafted with one cost-oriented battery, but 4 gold ingots on the corners. Now, the life-oriented battery has the same stats as the cost-oriented battery, but its life will drop quite a bit slower. So if you want your battery, if you don't want to have to replace your batteries, use the life-oriented ones, only 4 gold. It's not that hard. And then it looks the same as the capacity-oriented battery, but instead of white drips on the top, it's yellow drips. And so those were the batteries. There is one more type of battery, and that is the voltage-oriented battery. But it has a voltage of 200 volts, so it's not going to be words are hard. It's not going to be much use to you since, as of now, you're probably using 50-volt machines. So the 200-volt battery will explode your machines and lights and stuff, as of now. You can get higher voltage machines. But yeah, so those were the batteries, and let's move on to this, the solar tracker. It's crafted using 3 glass panes, 2 redstone, 1 nether quartz, 3 iron. That gives you 4 solar trackers. Now this thing's pretty simple. Basically, you go up to one of the rotating solar panels, you take it and you put one in, and then automatically it will try and tilt it. It'll tilt itself towards the sun for the max possible efficiency, which is nice. Efficiency is good. Okay, so that's the solar tracker. Very useful. They're pretty cheap. I do definitely suggest making them if you are going to be using the rotating panels, which you should be. So that was all the crafting recipes. Now let's get into actually how to use some of these machines. And to make my life easier, let's just set this to day. Yeah, so let's take a look at the water turbine. So you can see here, you put it down, you put some water under it, it'll start spinning. Now the power output from this thing as of now, it does not change from how far away the water flows. It has a constant power output. Basically, is water flowing underneath? Then it outputs the power. Now, you can see it's just spinning here, and you can see it's outputting less than the amount it said it would. So it's supposed to be outputting 30 watts, but it's only outputting like 25. And that's partly because of this. Actually, no, that has nothing to do with the furnace. Never mind what I was about to say. But yeah, you can see its power output is not constant though. If you look here, you can see it does have a bit of a curve. It was going down, but now it's increasing now. So the power does not stay steady. It fluctuates a little bit. And the wind turbine here is almost dead. Jeez. Yeah, but something about this thing is if it rains, you can see the power output should spike up dramatically. Yes. Up it goes. Up it goes. Now, this thing, when it rains or there's a thunderstorm, or I think the snowing affects it too, because that's still technically rain. If there's a storm or thunderstorm in your world, the water turbine it'll basically, I think it'll almost double its output power. But that's I'm just kind of guessing there. But, yeah. and its output power is a, let's see, it is, what is its output power right now? It's probably, like, less than 50, but that's just because the furnace there is pulling it down. But yeah, so that's the water turbine. It's pretty simple. It makes power if there's water. Simple. Now let's move on to the wind turbine. This thing is it's still pretty simple to set up and use. It's just, it's not as, I don't know, it's not as easy, let's say, to get power out of it. But yeah, so you can see this thing here, we're kind of, if you remember, its power said 160 watts. Now, this thing is definitely not making 160 watts right now. It's making, like, none. It's not making any power. And that's just because we're unlucky right now. The winds died down, and the wind does that. So you can see its power output is also very unreliable. So you can see it goes up and down and up and down and up and down. And then sometimes with it down here, its power output might go up to 80, but mostly if it's down near the ground, you're not going to be getting very much power output from it. Now, this thing, you gotta remember, I'm at a fairly low Y level of, what am I at? I'm at, what, 27? Y27? That's pretty low down. So the lower this thing is down, the worse it's going to be. So the higher up you can place it, the better. I'm going to go talk about that for a second. So let's just go up to this platform I made up here. Now, as you basically, the higher up this thing is built, the better. But basically the boost you'll get from putting it higher up will stop at Y level 100. So once it's at 100, you can see it stops. So you can see we are generating more power here, just less. And it does seem this thing was making before, when I was just finishing off this area here, this thing was making like over 200 watts of power, but it seems the wind is pretty slow right now. So this thing is pretty unstable with its power, even at the highest altitude of 100 meters up. Let's head back down to the ground. Now, during rain, if you would notice, this thing's power output will increase during the rain. I said increase. There we go. So, yeah, you can see we're getting, what, 8 watts now, but again, this thing, very unstable, but when it is nice, when it is producing lots of power, it works. Now, this may or may not be a thing, but from playing around with it, it may or may not generate different amounts of power depending on what biome it is in. From playing around, it seemed that the mountain biome, putting it in the mountain biome, generated the most power, but that could have just been, it may not even do that, it may have just been me, but yeah, I don't know. So let's move on to the solar panels. Now you can see we got the 2 solar panels there. Now let's set this today to show the difference between the 2 solar panels. So you can see for the small flat solar panel, you can see as the sun rises, its power output will slowly increase. But with the rotating one, you can see as soon as the sun is up, this thing is making the peak amount of power. So it's for the just 4 iron and the solar tracker, it's much worth it putting in there. Yes, much worth it, words 100. It's very much worth it making the rotating one. Just looking at the power output here. And if we set it to noon, where the sun is, where they should both be getting perfect from the sun, you can see the power output of this one is still higher than the flat one, because putting a solar panel flat on the ground is the least efficient way to put them, in real life too. Yeah, but during rain, let's just set it to rain, you can see the power output will drop down a bit during the rain. But it doesn't drop down too much. It drops down, but it's still going. Let's turn the rain off. So those were how you use the things. They're pretty simple. I still have some more to talk about over there. But also, with the solar panels, don't place anything above them. They need line of sight to the sky. And I believe that's basically it. As long as they have line of sight at the sky, I think they work through glass. Let's just check that. check to see if that's true. Let's grab ourselves a glass block here. Let's place it above this solar panel here. And let's see. Yeah, power output is the same. So glass and barrier blocks probably do not stop the sunlight from getting to these things. So those were the power generating items. So let's move on to a couple other things that will be useful for when you're making your systems. So first, let's take a look at this thing. This is the electrical probe chip. Now, to craft this thing, it's for redstone and high voltage cable. Now, the high voltage cable is pretty easy to craft. It's basically, you take the low voltage cable, you put some rubber on it, and then you take that medium voltage cable you got, you put some rubber on it, you get your high voltage cable, there you go, you got your voltage probe chip. Now, there's this other chip, which is the thermal probe chip. Now, that's crafted using 2 copper ingots, 1 iron ingot, and 2 redstone. That gives you 1 thermal probe chip. These chips are used to build meters. So this is the multimeter. It's crafted using 6 rubber, 1 glass pane, 1 redstone, 1 electrical probe chip. And this thing is very useful. I highly suggest making one. I don't even know if it's an option. I think you have to craft one of these if you want to know what's going on with your systems. Like, if we look at this wire here, you can see it's at its 14 volts, and it basically measures the voltage, it measures the current, and it measures the total power. And it's just very useful and very good, and you should very much make one. Let's move on to this thing, which is the thermometer, which is crafted the same way, just replace the electrical probe chip with the thermal probe chip. And this thing does the same thing as the electrical one, except it tells temperatures. So this is useful for taking a look at, like, if your wires are about to overheat and explode, or useful for checking if your batteries are about to overheat and explode. It's good for checking the temperature of things, which will be useful when you're generating high power systems, whose wires are about to explode at like every moment. But yeah, and if you don't want to have to carry 2 separate meters, you can put them together to get the universal meter, which basically it measures both the electrical things and the temperature things. Nice. Yeah. So let's move on to a couple other things. This is the overheating protection. This is for batteries, and it's crafted with a thermal probe chip, a cheap chip, and 1 redstone. That gives you 4 overheating protection chips, and 1 electrical probe chip, 1 cheap chip, and 1 redstone is an overvoltage protection. These things are useful. You'll probably want to, if you're making big battery banks, you're going to want to use these just so you don't blow up all your precious batteries. And if you want to know how to craft a cheap chip, that's in episode 2. So let's move on into some other stuff here. I will need the universal meter. The universal meter. Let's just grab this for a second. So if you take a look here, you can see it has some batteries lined up. So for these panels, if you remember, each panel only produced like 14 or whatever, 14 point like something volts. Let's just set this to day again. Now you can see if you line 4 of these up, make sure, so basically if you, blue side is ground, so let's just show how to use these. You put your ground cable, make sure it's connected to the blue side, and let's just grab a normal wire, not a battery, a wire, and your power comes out the red side. You can see we got our 14.8 volts there. Now if you put another one on, make sure the power comes out of the red side and goes into the blue side, like that. Just putting them beside each other, they'll connect. You can see the power output has then, the voltage output has combined both. And if you put 4 of these in a row, your voltage output is a nice 59 volts exactly. And what also produce 59 volts? Well, the wind turbine and the water turbine. So putting 4 of these things together is enough to run your systems and charge your batteries. So that's nice. Now, if you remember, these capacity-oriented batteries they're only like 12-volt batteries. Well, if you put them together in series like this, it'll output 50.6 volts. Now, if we take a look at a normal battery, it also outputs 50.6 volts. So you can equivalent a battery by putting 4 of these together, except this thing is like many, many times the storage of this thing, this one battery. So yeah, that's why you'd want to do that. But I have found these capacity-oriented batteries tend to drop, their life tends to drop faster. So if you just jump over the wall here, take a look at these batteries here, you can see One thing I should have mentioned earlier is the life on the batteries will not drop below 10%. So you can see these batteries here only have 10% of their initial charge. But at full charge, above full charge, I charge these to 103%. With a life of bare minimum, these things are barely storing any power, only 24.8 kilojoules per battery. That's not a lot of power. Like, all of these together are only holding just more than one cheap battery. So, yeah, make sure to use batteries which won't lose life. Now, I don't know whether these batteries just lose life faster, or putting them in series like this with the increased voltage makes them lose life faster. Might be both, might be just one, but yeah, so I would suggest using life-oriented batteries because you won't have to replace them. So let's move on. So if you remember these single-use batteries from before, oof. 1 second, please. Okay, I has returned, and all I did was basically drain this battery. Now, let's just get, okay, I just drained the battery, that's all I did. And the single-use battery, so if you remember, these machines over here from the last episode, they draw quite a bit of power, and they will drain these single-use batteries quite quickly. So if you do have a pile of dead single-use batteries, don't burn them in lava quite just yet. Because if you hook them up to power like a normal battery, what is it doing? Oh, it's charging. They can do, apparently you can charge the single-use batteries. Now these things are quite good. They store, let's just take a look here. They store double the power of a normal cheap battery. Their life will never go down, because they don't technically have a life. And they have a high power output. They are very good battery. It's just, I don't think this is an intended purpose though. I don't think you're supposed to be able to charge these things. Well, you can. So feel free to use them while you can. So yeah, you can charge these single-use batteries. So basically, if you're wondering how to charge one of these batteries, it's pretty simple. You hook the battery up like normal. Don't hook the power to the negative or anything like that. That's bad. That will blow up your battery. Don't do that. To charge them, basically, hook the negative of the battery back to the ground cable like normal. Hook the positive up to your circuit, and then have some sort of power generating thing in it. Let's take a look there. Let's just wait for this thing to speed up. There we go. Now, if you flick this lever, you can see the battery's charging. Now, these batteries output, what was it, 50.6 volts? And these things output 59 volts. So if the voltage of this thing is higher than the battery, so basically, if the voltage you're putting into your circuit is higher than the voltage of your battery, the battery will charge. So basically, if the circuit is higher, if the circuit is a higher voltage than the battery will start pulling in power from the circuit. Pretty simple. Just, yeah, that's it. So, yeah, pretty simple. Now, let's just go over these overvoltage and overheat protections. Now, this furnace has the tungsten heating element in it, or heating corp, and it pulls 500 watts, well, a bit more than 500 watts, but this battery can only output 250 watts, so it's going to be pulling out double the amount of power that's supposed to be coming out of this battery. Now, if we just turn this on here, this battery should explode. Let's take a look at the temperature, but the temperature never reaches 50. Now, I don't know what temperature these batteries explode. It's probably like 100 or something. But this thing is pulling power. But if we look at the power here, the power is flickering on and off. And that is because the overheat protection. The overheat protection will turn the battery off if the battery's temperature ever reaches close to 50 degrees Celsius. And it will keep the battery off until it reaches like a couple degrees below. Which is why this battery keeps turning on and off. Now let's just showcase what'll happen if you didn't have the overheat protection in there. This is the right battery, right? Yeah. Let's just place these things down. Wrong way around. There we go. Now let's put the heating corp in there. And you can see this battery's nice and okay. The battery temperature is heating up. It's past 50. It's already up 60, so the temperature will basically increase, and once it reaches 100, I think it explodes. Yeah. And there you go. So the battery would explode if the protection wasn't in there. So you use protection in your batteries. Use protection in your batteries, kids. Oh, that's kind of cursed. Now, I think that's the last thing I have to cover in this video. So, yeah, like if you liked the video, subscribe if you want, and thank you for watching.